All right, welcome to your notes on Python and sound. That's right, we're moving on from pictures and taking a look at now how we can manipulate, modify, interact with sound files inside of our REPL Python environment. All right, so before we get into Python specific stuff, let's just talk a little bit about sound in general. So sounds are basically alternating waves of high and low air pressure. All right. They come in cycles, and the frequency of a wave is the number of cycles, which is basically an up and a down per second, which is generally measured in hertz. So for example, in this picture here, this would represent one cycle because we're going up, down, and then back to our starting point. So this right here would be one cycle. All right. Now, the other term that's going to be important for us going forward is the amplitude. Is the maximum height of the wave. So a lot of what we're going to be dealing with is talking about modifying frequencies, modifying amplitudes, modifying the heights of the waves to create different effects within our sound files and to manipulate them sort of in different ways. All right, so amplitude is related to volume. So higher amplitude is associated with higher pressure, which is then associated with louder volume. So if amplitude doubles, it's about a 6 decibel change. So decibels work on sort of a logarithmic scale. And just for like a kind of a simple reference here, normal speech is considered about 60 decibels. Shouted speech is about 80 decibels, just to give you sort of a kind of a frame of reference there. So if we're looking at this wave here, these sounds would be quieter, and these sounds over here would be much louder. All right, so again, not in any way really related to programming itself, but just some general information about sound so that when we do start interacting and modifying it programmatically, you have an idea of what we're modifying and why it has the impact that it has. So volume is determined by amplitude, and then pitch is determined by frequency. So the higher the frequency, the higher the pitch. We can generally hear between 5 hertz and 20,000 hertz, which again is kind of cycles per second. All right, cycles per second. And then I'm not a music person, but again, for a frame of reference, A above middle C is 440 hertz. So again, this right here represents one cycle. And as one cycle, this would be a lower pitch. And then if we were in that same period of time to have, let's say, 1, 2, 3, 4, 5, 6, 7, 8 cycles, it's sort of an equivalent period of time, that would give us a much higher pitch. So again, we can change the volume by playing with the amplitude, and we can change the pitch by playing with the frequency. All right, so how is this all actually digitized or, recorded on a computer? So analog to digital conversion records the amplitude or the height of the sound wave at regular time intervals. And the recorded amplitude values are called samples. All right. So again, a wave is sort of a continuous object. So, by that I mean there are an infinite number of points on this line, but obviously we can't store an infinite number of points. So what we do is we pick an interval and then just record the values at that interval and kind of use that to represent the sound. So each of these dots here basically represents a sample. So what we would do is we'd say, all right, at an interval, that might be one of our sample values. And the height of the wave at this time is our sample value. All right, so we're basically just measuring the height of the wave at fixed intervals. Now, how many of these samples do we need to sort of accurately, represent the wave? So a common sampling rate, not the only sampling rate, but a common sampling rate is 44,100 hertz is a very common sampling rate. So what exactly does that mean? It means that for every second of sound, we're recording 44,100 amplitudes or wave heights. All right. So quite a lot of data for just a single second of sound. And that sampling rate, interestingly, is kind of based on like the physics of what the human ear can actually perceive and pick up. So there's a point where it wouldn't make sense to sample at much higher than 44,000 because the human ear wouldn't really be able to detect it or pick up on that. So by taking enough samples, it basically fools the ear into thinking it's a continuous sound wave, even though it's really discrete measurements taken at sort of a fixed interval. Now, how is all this information actually stored? All right, so sample values are stored in what's called an array, which is basically just a continuous sequence of bytes in memory. So for example, this sample would correspond to this value, this one would correspond to this value, and so on and so forth. All right, we would just have a contiguous spot in memory, and each of these points on the wave would correspond to a point in the array. All right, I think you get the point here. I don't think I need to draw any more lines. All right, so each array entry stores an integer that is the height of the sound wave at a point in time. And again, not that this is a physics course, but I probably really shouldn't have said amplitudes back here. Amplitude is kind of referring to the max height. The samples are just the specific wave height at that point. Again, not anything that's a huge deal for what we're working with, but in the sense of accuracy, I probably shouldn't have used the words amplitude there. All right, so let's bring it over to actually sort of the programming piece now. So first of all, to record our sounds, we're going to be using a program called Twisted Wave. And I will post a separate video that just kind of walks through how that works and how you can interact with it. But instead, let's just talk about some of the commands that we're going to be seeing here. Now, a lot of them are going to be very similar to what we did with pictures. So when we were dealing with pictures, we had like make picture, and then we had to provide the name of the picture. Now we've got make sound. All right. With the pictures, we had like get width, get length. All right. Now a picture doesn't have a width and a length. A sound doesn't have a width and a length, but we can use get sampling rate if we want to know the sampling rate of the sound file that we're using. Because again, 44,000 is common, but it's not the only one. And in fact, in this one, we're actually going to use mostly 22,000, just so that things don't take as long to process. And then the get length will tell you so this will tell you the sampling rate, and get length will tell you the total number of samples. And then again, sampling rate will give you the samples per second. But a lot of the commands are going to be very similar to what we've been doing. They're just going to relate to audio as opposed to, visual that we had been working with. All right. So let's talk about manipulating a sample value. So here we have the command s equals get sample value at. All right. You can sort of think of this as the equivalent to get pixel. All right. So in get pixel, we had to provide like an XY location. With set value at, we have to provide the sound and then the index. All right. So remember, sound is going to be stored in like an array of integers. So, you'll have different indexes and then you'll have different values. And let's just pretend this one is like -10. And let's pretend this one is, -30. And then maybe, there's more after that. And then up above here, we'll just say, okay, this is index 213. This is index 214. This is index 215. This is index 216. All right. So again, when we say get sample value at, we might provide, an actual file. So it might be like s equals get sample value at, my sound dot wave, and then we'd have to provide an index number, and that would just again be the location in memory. And much like our coordinates started at 0, the first index is going to start as 0. The same way that when we did strings, the first letter was at 0. Same thing with sound. It's that same numbering system where you start at 0 and the last index is one less than the number that you have. So if you took 10 samples, they'd be numbered 0 to 9. So again, you would just provide an actual number here like, oh, I want sample 7 or whatever. All right. And then we've got the set sample value at, which you could think of that as like setting the color when we were dealing with pictures. Only now we're going to be setting just a value. All right. And that's going to be the set number that we're dealing with. All right. So let's look at the sample code here. We've got s equals make sound example.wave. So that creates this sound object inside of s that we can interact with. We can say set sample value at s index 214 and set it to 0. So that would take this value right here that, started off as -10 because that's what I made up. And it would say, all right, we're getting rid of that. And we're changing that sound value so that instead of being a -10, it's now a 0. All right. And then if we printed get sample value at 214, that would print out a 0 because we've just gone in and set that value. All right, so a lot of the same things that we could do with pictures, we can also do with sound. All right, so I can also say get sample value at S215. All right, so that's storing it in variable V. So originally it was a -30, so I could be, okay, that's going to print out a -30 because that's just an integer. It's storing an integer. All right, this right here returns an integer value. And then again, we could use this set sample value at, and in this case, it would change it from 215 to, 30,000. So now all of a sudden, this would have 30,000 inside of it. And then if we printed it, it would print out that 30,000. All right, because that's going to return the integer, and then we're just going to print out the integer. All right, so we've got all sorts of functions that are built into Jest that can allow us to make a file. They can allow us to change individual values. They can allow us to retrieve individual values, much like we could with the pixels inside of our pictures. All right, so let's look at some actual programs that modify a sound in one way or another. So here we have a recipe to increase volume. All right, so if you wanted to write code that would, make a sound file like increase in volume, and I don't just mean like turning up the speaker, but making it seem louder regardless of what, the volume on your speaker is set at. And that's part of why, like, you can have your TV at the same volume and like a commercial will come on really loud and then you'll go back to the show and it'll seem really soft. The volume that you set on like a TV or a computer is like the maximum allowable, but then the actual file can sort of use up to that maximum, but it can't go above that maximum. So long story short, by changing the amplitude or not the amplitude, but the wave height, and making it larger, you can make a sound appear louder, even if you don't actually like change the volume on the machine itself. All right, so quick aside there, let's take a look at this code. So we have a function, def increase volume. All right, the parameter it's being passed is a sound object. And then we have for index in range. All right, so 0 to get length of sound. All right, so index is going to be an integer that starts at 0 and then goes all the way up until, you reach basically 1 less than the length. And then each time through, we're just getting the sample value. All right, this returns an integer. All right, and saves that integer inside of value. And then we're setting the sample value at, so we're going and using that same index. All right, these are the same index, only we are doubling the value. All right, so this would go through and just double every value inside of that string of numbers or array of numbers and make the sound appear or perceived louder. As far as actually running this code, it's going to be the same type of thing we did with pictures. So we've got s equals make sound, which is the same as like, my pick equals make picture. We call the function and we pass in our sound object. And then instead of write picture to, it's now write sound to. You provide the object, you provide the sound file. So again, a lot of this is going to feel very familiar because it works in the same way. We're just using different files here. All right, so here's an example of one function that, would go through and increase the volume. Now, let's just take a closer look at exactly how that would all play out. So in our little example here, our sound only has 4 samples. So super, super tiny. And this right here represents our sound. So these right here represent wave heights. All right. And again, the index would start at 0 and then go up from there. So even though the length is 4, 1, 2, 3, 4, they're numbered 0 to 3. All right. So again, for index and range 0, 4, this is going to give a 4, but we always remember that it cuts off the last one. So it's really only going to give us 0, 1, 2, and 3, which conveniently is exactly what we need. So all that's going to happen here is we're going to go through and we're going to say, all right, when index is 0, we're going to get the value 3, because that's the existing value. Then we're going to double it, and this 3 is going to become a 6. Then when the index is 1, we're going to retrieve the 8. We're going to double it, and that 8's going to become a 16. When the index is a 2, we're going to get a value of 10. We're going to double it. That 10 is going to become a 20. All right, and when that index is a 3, the value is going to be a 7. And then we're going to double it, and it's going to become a 14. All right. So again, very similar to going through and like changing the red of a pixel or changing the blue of a pixel. And in some ways it's easier because instead of having a red, green, and a blue, we just have a single amplitude that we're changing, not amplitude, wave height that we're changing, as opposed to having like 3 different things that we have to worry about. All right. So let's take a look at some other sort of functions here and analyze what they do and sort of the impact that they will have. So it says, for each of the following mystery functions, show what it will do to the example sound array if it is given as input, then describe in plain English what differences you will hear in the recording of the Gettysburg Address if it is given as an input to the function. Be clear and precise in your description. So the Gettysburg Address is one of those like sample files we'll have. So when we're kind of messing around with things, that's one of the sample files we'll be able to use to see the impact that everything has. All right, so what do we have here? We have a loop for index in range from 0 to get length of sound divided by 2. All right, value equals get sample value at, and then set sample value at sound index value times 2. All right, so this one's very similar to the one we just had. The only difference is we're dividing this get length by 2. So again, in our sample sound here, we have 0, 1, 2, 3, 4, 5, which means this length is actually 6. So 6 integer division by 2 would give us 3. So that means our range is going from 0, 3, which means we're really only getting 0, 1, and 2 because it doesn't go up to that last number. So it's going to double the values, but it's only going to double these first 3. So -8 would become -16, -2 would become -4, +4 would become a +8. So much like the one we just looked at, it increases the volume, but of only the first half of the sound. So again, this one was pretty much identical to the last one we looked at. The only difference is, we're only going through the first half of the sound. All right, let's take a look at another one. Mystery sound 2, for index in range, get length of sound divided by 2 to get length of sound. Value equals get sample value at, set sample value at, sound index value divided by 2. All right, so let's start with this part right here. Again, we're using the same length of 0, 1, 2, 3, 4, and 5, which means the length is again this 6 divided by 2, or 3. So this is basically giving us a range of 3, 6, which means the indexes that we're actually going to be accessing are 3, 4, and 5. Because again, that range starts at 3, but then it goes to 1 less than 6. So we're only going to be looking at this part of our sound. All right, and then we're retrieving the sample value, and then we're basically dividing it by 2. All right, so this 8 would become a 4, this 20 would become a 10, and this 10 would become a 5. All right, so in terms of what it's actually doing, when you double it, you're increasing the sound. When you cut it in half, you're decreasing the volume for the back half of the sound. All right, let's see what Mystery 3 is doing. So this time we're back to starting at 0, but now we're going to get length of sound divided by 2, which at this point we've kind of already established is going to give us just the first half of the sound. All right, because this is going to be a range from 0, 3, which again is only going to give us 0, 1, and 2, or in other words, this first part of our sound file. Now, what is it actually doing with that? All right, so we're still doing the value equals get sample value at. That part's been the same every single time. Only this time, we're not like doubling it or dividing it in half. We're literally just zeroing it out. All right, so instead of having -8 here, it's just going to drop to 0. Instead of having -2, it's going to drop to 0. Instead of having a 4, it's going to drop to 0. All right. In terms of what effect that's going to have is if the wave doesn't have a height at that point, you're basically not hearing anything. All right. That's basically silence. So the first half of the sound the volume goes to 0. And you're basically not going to hear anything. All right. So again, just different sort of variations of the same thing, but just getting used to this syntax of get sample value at, set sample value at, because that's a lot of what we're going to be using and what we're going to be doing when we interact with these various files. All right, let's take a look at another one here. Mystery 4. So this one's a little more involved, but again, same sort of things going on here. So for index and range, get length of sound divided by 2, comma, get length of sound. So again, 6 divided by 2 is going to give us a 3. The length is going to be 6. So when we do 3, 6, or range 3, 6, it gives us 3, 4, and 5, aka the back half of our sound. Now we're getting the sample value at, just like we have been every other time, but now we're incorporating this conditional or this if statement. So we're saying if the value is greater than or equal to 0, which is basically another way of saying if positive. So if the value is positive, set it to 32,767. Else set it to, which again is basically negative, set the sample value to negative 32,768. Those are actually the max and min values. And we'll talk about why those are the max and min values a little later on. But basically, those are the max heights that you can set when you're modifying your sound. All right. So in terms of what it does is it basically maximizes or minimizes the sample values in the second half of the sound. And again, there's going to be a file that I share with you so you can like test all of these things out and kind of see what they actually do and the impact that they have and so on and so forth. But basically, going back up here, this one's positive, so it would get set to 32,767. This one's negative, so it would get to negative 32,768. And this one is positive again, so it would go to positive 32,767. All right. So again, a little more involved, but same general idea. Retrieving indexes, or retrieving values, and then changing those values to create some sort of effect or some sort of modification with your sound. Now, two other things that are built into our just.py file that are going to be very useful when we're using this unit or doing this unit are copy and clip. All right. So what do both of these do? All right. So copy, shockingly, copies the source sound into the target sound starting at the start position. So if this is your source sound, which you have to put first when you're using the function, it's going to get copied into the target sound at whatever start position you specify. So a couple of things to note. The target sound must be large enough to hold the source sound. So, this can't be bigger than this, or if you're not starting at the beginning, but you're starting it halfway through, there has to be enough room for it. All right. It can't like overhang. You've got to make sure that there's enough room for this sound to actually be copied into here. And just some other things to just be aware of. The source sound is going to be unchanged. So if this is your source sound object, this one's going to be totally unchanged, where the target sound is going to be changed. All right. You're copying something into it. You're modifying it. So this one's going to be changed. This one is going to be left unchanged. All right. The other one that's going to be useful is this clip function. And this makes a new sound that is a clip of the sound from the start position to the end position, not including the end position. So this is exactly like range, where if you put in a range of 0 to 3, it only gives you 0, 1, and 2. Now, with this, the sound object itself is going to be unchanged. You're not actually modifying that. This function just returns a sound. All right, so this whole thing is going to return a sound object that we're either going to feed into another function or we're going to save it and give it some sort of label here. All right, so it returns a sound, which is the shorter sound, the piece that you clipped off. So again, as we work through some of the activities and labs, these are two things that have become very useful to us and that we're going to use over and over and over again. All right, so let's take a little closer look on how these are going to function and actually work inside of it. All right, so if I were to call clip with my sound and specify 2, 7, all right, what is that actually going to get us? All right, well, the first thing to remember is that 2, 7 is really only giving us 2, 3, 4, 5, and 6, which means it's basically clipping this part of the sound right here. All right, and then it's saving it into short. So short's going to be this new sound object that only has these 5 measurements. And it's basically going to just put the first one in here. So the negative 4,500 is going to go in here. The positive 1,500 would go in here. The positive 100 would go in here. The positive 30,000 would go in here. And the negative 10,500 would go in there. And just kind of remember, these are all, wave heights. So basically it creates a new sound from these 5 samples. And down here is our new sound with a size of 5. All right. Main thing to remember, the main thing that can trip you up is just remembering that 2 to 7 is really only giving you 2, 3, 4, 5, and 6. All right. That's probably the most common mistake that kids are going to make when trying to figure out or analyze what this is actually doing. All right. So this is clip. And then let's take a look at copy. All right. So if I were to write here, copy S1, my sound, 5. All right. Remember, the first one is going to be your source. The second one is going to be your target. And this is going to be your starting position. So again, that means the source is going into the target. So in this case, we're copying S1, which is down here, into my sound, and we're starting at location 5. So this first box is going to go right here at 5. The next box is going to go in at 6. The next box is going to go in at 7. And the next box is going to go in at 8. But we're just copying each of those into its appropriate location. So instead of this being 30,000, it's now going to be overridden and it's going to have a 500 there. Instead of being this negative 10,500, it's going to have another 500. Instead of it having 5,250, it's going to have another 500. And then finally, instead of negative 4004, it's going to have negative 500. So it just takes a smaller clip and copies it into a location. And again, it's important to make sure that you have room to copy it. And in this case, we do. So we're totally fine there. All right. But again, 2 things that we're going to be using a lot in our labs, in your eventual homework assignment with this, is this copy and clip. All right. So making an empty sound. All right. This is something that we're going to need to also know how to do. Kind of similar to making an empty picture. So again, hopefully all of this kind of looks or feels a little familiar to you. So it would just be something like my sound. Again, this is just your choice. It doesn't have to be my sound, but whatever name you give it equals make empty sound and then length of new sound. So an example, you could write something like empty S equals make empty sound 60,000. All right, and then that would basically just create a big long list of numbers that are all going to have zeros in them, right? Because it's an empty blank sound all the way to the very end, which is zeros. And again, the first index is going to be index 0, and then 1, 2, 3, 4, all the way up to 59,999. All right, but this would be our empty S, just a big long list of zeros, and those zeros just represent the height of the wave. So if the height of the wave is 0, you basically just get blank sound. All right, so we're going to use this, make empty sound, and then we're going to like copy things into it and modify it and do all sorts of different things to kind of create effects and stuff that we want to do. All right, so let's say we wanted to combine two sounds into one. All right, so here we've got S1 equals make sound using a file called always.wave. Then we've got G equals make sound, gettysburg.wave. All right, and then we've got S2, which is going to clip part of G, and specifically from 10,000 to 34,999. Because remember, even though it says 35,000, we stop kind of one short there. All right. So we're going to start with combo equals make empty sound, and we have to make sure that the sound is big enough to hold everything. So let's say we were trying to combo together and create S1 and S2. If we want to make sure that it's big enough to hold both of those sounds, we can just say get length of S1, which is going to return an integer, plus get length of S2, which is going to return a second integer, and then we're guaranteed that it's going to be the correct size. Then we could say, all right, well, I'm going to copy in S1. All right, so again, when we're using copy, this first one is our source, and we want to copy it into our target file, or target sound, which for us is going to be combo. So again, this is our target. And then we have to specify where we want it to start. And if this is the first sound that we're putting in, we would just start it at 0. Now, where do we want to start the next one? All right, well, we're going to copy in S2. We're going to, again, copy it into the combo sound. Now, as far as where we're going to put it, we're going to put it at get length of S1. Now, remember, it can sometimes be tricky because like it starts at 0, it goes to this, it goes to that. But this is going to work out perfectly because let's say that S1, I'm just going to make this up, had 10 samples in it. All right, this would go from 0 to 9, but the length would be 10. So this is starting at 10, which is one after the end of this one. So we can just say get length of S1. We don't have to do like +1 or anything like that to modify it. This is going to perfectly put it right after the existing sound file. And then we'd have both of those just back to back. And then this would actually write it out to a file so that we could hear it and see what it actually does. All right? Because if we don't actually write it out to a file, we're not going to be able to see what we've accomplished or what's happened with that. Okay? So last but not least, I said a little while ago we were going to talk about why those values were the min and the max. So in REPL, each sample is stored as a number in 2 bytes, right? And we need to be able to store positive and negative sample values. So if the min and the max values are represented with a 2-byte sign magnitude, 2 bytes equals 16 bits. All right, sign magnitude, we learned in the very first unit, uses 1 bit for the sign and then 15 bits for the value. All right, so the largest and smallest sample values we can find by saying, okay, well, the largest value is going to be 2 to the 15th minus 1. All right, and the reason we're subtracting 1 is because, remember, we have to count 0. So it's 2 to the 15th different values, and those range from 0 to 2 to the 15th minus 1, or 32,767. And then the smallest value, it's the same exact logic. It's basically negative 2 to the 15th minus 1, which is negative 32,767. All right. Now, a little note down here at the bottom. In Python, the minimum sample value is actually negative 32,768. This is because it uses something a little more sophisticated than sign magnitude. One of the problems we saw with sign magnitude is that there was actually this redundant positive 0 and negative 0, which was kind of wasteful because you had 2 different bit sequences that represented the same value, since there really isn't a positive or a negative 0. So instead, they sort of reclaim that extra value and put it on the negative side. And if you want to know exactly how that works, you can read about it in your Python textbook in section 7.14. All right. So again, that's just a little insight if you're wondering, like, why is that the max value or why is that the minimum value? Again, it goes back to that data representation stuff that we talked about at the very beginning of the course. All right, so that's kind of the rundown for sound. Again, very similar to what we did with pictures. Obviously, the functions have slightly different names, but we're doing a lot of the same sort of stuff. We're going in, we're retrieving values, we're modifying those values, we're writing them to different files. So a lot of the stuff that you did with like your picture collages is what we're going to be doing with sounds. We're going to modify things and then write them to empty files to create something new and different. All right, so I hope this was helpful. And as always, if you have any questions, just let me know and we'll go from there. All right.